their knowledge and skill in this emerging field. The objective of this FDP is to provide you with a comprehensive overview of the concepts, techniques, tools and application of big data analytics. You will learn about the challenges and opportunities of big data, the characteristics and source of big data, the architecture and component of big data systems, the method and algorithm for big data processing and analysis, the tool and platform for big data analytics, and the application of big data analytics in various domains. We are fortunate to have eminent resource persons from academics as well as from industry who will share their expertise and knowledge with us during this FDP. I would like to express my sincere gratitude to them for accepting our invitation and sparing their valuable time for this program. I would also like to acknowledge the efforts of Ms. Sonia and all the staff members of BCIIT who have worked hard to make this FDP a success. I hope you will find this FDP useful and interesting. I urge you all to actively participate in the sessions, interact with the resource person and your fellow participants, and make the most of this learning opportunity. I wish you all fruitful and enjoyable FDP. Thanks a lot. Uh, I request Sonia ma'am to please continue the session.
Thank you so much, sir. Now I request Dr. Prashant Gupta to carry on the session. Welcome, sir. Sir, you are not audible. Please wait for a minute.
Am I audible now?
Yes, sir, you are audible now.
Okay. Thank you, Sonia ma'am, for this honor and such a nice introduction. And I think there is not much that needs to be done still, but yeah, still I'm trying to like learn and move ahead in life. So thank you so much again. And also thank you for inviting me as a resource person. So let's delve into what we are here today. Ma'am, I cannot share my screen. Uh,
Just a minute, sir. Sir, please take it now.
yes, ma'am.
Are you able to share it?
Can you
Yes.
see my screen now?
Sir, it
Okay.
is blank at the moment. Nothing is
Okay.
visible.
Let me share again. Now, can you see?
No, sir, it is blank. Yes, sir, we can see it. Yes, sir,
Okay.
it is visible.
Okay. So, like, first of all, thank you everyone for being here, and let me begin. So, today I will be discussing the big data architecture and big data technologies, and just try to share my knowledge with all of you. So, this is a brief introduction about me, which Sonia ma'am has already given, and this is my webpage where you can find me. Presently, I am working as associate professor at Bennett University, and this is my email ID if in case someone is interested to get in touch with me. Okay, so these are the brief things that I'll be discussing. So I'll be discussing to before understanding I feel about the big data architecture, it's very important to understand what big data actually is. So I'll be giving some introduction to the big data. Then I'll be discussing about the big data architecture, how to organize the big data, what actual big data is, what are the challenges, how to deal with it, and things like that. Because being computer scientists, we all know that data is a raw form. And when it processed, then it becomes the information, or useful patterns can be derived from that and can be used for different types of applications. So what things we require in terms of architecture holistically, from the storage point of view, from the governance, data processing, and things like that. Then this is a generalized pattern that we will see. Then how that is implemented in practice. So that is by the big data architectural patterns we'll see. And we'll broadly see two architectural patterns, Lambda and Kappa architecture. Then we will move on to the big data technologies. And like mainly popular ones are the Hadoop, Cassandra, and Spark. After that, we'll be discussing in detail one of the big data technologies, how the data is organized in terms of the what are the different data flows and different things like that. And finally, I'll be giving you people the references in terms of the interested people who are interested in exploring this field further, in terms of the literature, in terms of the online resources or blogs if you want to consult and like later on. So let's see. Okay, so first of all, beginning with the introduction, what actually a big data is. So first of all, like we all use the smartphones nowadays, right? And in smartphones, we have different types of applications. We have messaging applications, we have calling applications, or maybe emailing applications, location access, media we all have. We have videos, we have photos, we have music, and different types of banking applications and different types of shopping applications, maybe for groceries and like things like that. And we all know like most of these applications require like access to your location and your other kind of access to your contacts and things like that. So all this is what? So any smartphone user, and because why I've taken this example to show about the smartphone user, because nowadays smartphones are more common than the laptops and the portable devices. So because earlier times they were like we had to have the desktop computers and then it was taken by the powerful laptops, and now smartphones are increasing in numbers with lots of powerful computations and capabilities. So smartphone users are way greater than the laptop or the computer users. And a smartphone users who use these mobile apps, and we go for different kinds of application usage. So there is a lot of data that a smartphone user is generating. So now this is just one smartphone user that is shown. What if we have like different number of smartphone users with different type of applications? And this is for maybe like about 1 day. And what if like that is the person is using the smartphone for a large and large number of duration, maybe like months and years. So you can imagine the amount of data that we are generating. And assuming that if there are approximately like it's by some estimate that there is approximately 40 exabytes of data that a smartphone user generates in a duration of 1 month. So assuming that there are 5 million smartphone users, so you can imagine how much data that we are generating with the smartphone only. Then on top of that, you can add the data from the laptops and things like that. So what to do with all this data? Where is all this data going? Definitely on there are different approaches that you can follow to deal with this data. One approach is that we've always called is the traditional approach, where you can have a machine on which you store the data, traditional machine, and then you can process the data. But as I just now showed you, like this much amount of data is generated in 1 month and with 5 million number of users. So you can imagine the amount of data that is being generated. So this is definitely not possible to store on one standalone machine, and definitely almost next to impossible to derive any useful patterns from this data, and what type of file structure we are going to have, and what type of processing tools will we require, because this is again humanly impossible to see all this data and derive useful patterns from this. So this is what is actually constitutes your definition, somehow loosely speaking, is the definition of your big data. So assuming that how much data is generated on the internet per minute. By some estimate, it says like there are 2.1 million Snapchats that are generated per minute on the internet. 3.8 million Google searches are performed every minute. Approximately 1 million users log into their Facebook accounts every minute. 4.5 million users browse through the YouTube videos or play through the YouTube videos, or by some estimate, they are active on the YouTube every minute. And 188 million people are simultaneously sending emails on the internet at in 1 minute. So you can imagine how much that data is. And we'll see how much that data in terms of the text and like different types of categorizations of the data is also an important factor that will come when we talk about the big data. So you can imagine this is what is actually your definition of, or loosely the definition of your big data actually, where there is a huge amount of data, like tons and tons of data that is there, and it is being generated at an increasingly large pace every moment, every second. Right now, we are also conducting this FDP. So during this time also, this data is being increasingly generated on the internet. People are out there, and searching on the internet on sending emails or like some kind of internet in activity they're involved. So this data is constantly being generated. So what the definition says, it says like big data is a data that contains great variety, arriving in increasing volumes with more velocity. And obviously, there are also related terms, two more related terms to this. There's veracity and the valuableness or value of the data. So as you can see here, like the data is already in great variety because we had the data, like we have the email data also, we have the chat data also, we have image data also, we have people logging into their Facebook account. So there's multimedia content, audio, and different types of whatnot data. And it's obviously arriving in increasingly large volume. So we just now saw, like from a smartphone user, or like every minute, how much data is being added and an increasingly high pace onto the internet every moment of time. And people will just now see the example where people have some websites and blog writing also. So every second people are writing blogs and things like that. So there's a huge amount of data that is in increasingly large volume that is coming up or arriving every moment, and with more and more velocity also. So there were before, you can see the advent of, you can actually, I'll say, like a digital revolution where like internet and things like that pervaded our life before that. So data generation was like very slow. If you remember like past years, so we had like very slow, or we had like very few social networking websites and things like that. But right now we have different social networking websites and like LinkedIn and like even Facebook and all the different kinds of sites, Instagram and LinkedIn. So there are different platforms on which the data is being generated. So even with increasing velocity, and some people use Instagram for Facebook for marketing, also for marketing ads and things. So the rate at which this data is generated, velocity is very high. Apart from that, these are obviously called the three V's of the big data. We have like two related terms also with this big data: veracity and the value. So veracity is like in terms of the big data, whenever we consider, so that is trustworthiness of the data. It should always come from the trusted source. And the last is the value, where it's very important, like in medical data, and we'll see where you can, in the last end of the video, in towards the last end of the talk or like things like that. So where you'll see where you process this data and you run different kinds of analytics on that. It is very important to uncover some customer trends. For example, if some marketing companies there like Amazon or Flipkart, whenever we go and buy some product online, it tries to show us the recommendations of the related products through the ads. So all this information is uncovered by use of this big data, where the data is collected of the customer and anal- through data analytics and things. Then you try to come up with recommendations to the customer. So just trying to uncover your customer's behavior and how the customer is expected to buy, what buying patterns the customer has, and frequency and different kinds of analytics. So this is where actually the value you generate. And one application can be in healthcare sector also. Director sir just now talked about the different kinds of machine learning algorithms that can be run on this big data, where you uncover the patterns, and maybe for healthcare applications, you can uncover a disease based on certain tests of the patient or body vitals. You can predict the occurrence of a disease and what are the chances and things like that. So this is how. Why we need it? Because you can actually say, as sir said, so this is actually a truth, that there's no going back in time. By this we mean that big data is actually the future or the reality, like believe it or not. So the data at the rate at which is being generated and the world population is increasing, so every number of smartphone consumption user increasing, and the society is increasingly moving towards the digitalization. From like even just talking about a simple example of a banking application. So there were times when people used to go to the bank in person. That was increasingly taken over by the internet banking, and now then there was mobile banking, and now we have come to the UPI and these kinds of payment system. So digitalization definitely is the future. Digitalization means that data will be generated at a very, very high pace and increasingly high pace. So one thing is for sure, that there's no going back in time. So big data is going to keep on increasing. Every moment, every second, the data is going to keep on increasing. So big data is the reality. Second is definitely the digitalization also comes up with the advantage of the data analysis. So we can analyze the data. For example, a marketing company can analyze and show the related or recommended products to the customer. In healthcare applications, you can predict the occurrence of a disease, and maybe like understanding like what can be the comorbidity also, like if one disease, what can be the co-occurrence of another disease and things like that. This kind of valuable information we can uncover, and then it obviously helps in the strategic decision making to any company. What all strategies to like upsell their product or cross selling of the product, or to better cater to the customers, understanding their needs if they have some grievances or concerns and things like that. And you can talk about like different kinds of motivations or different kinds of applications that these big data can have. So the list is like huge and huge. So compare, just like for the purpose of completeness, I'll just contrast big data with small data. There's actually no word like a small data, but small actually you can say like somehow like whatever the data that used to be there, or the volumes of the data in terms of like before somehow the advent of digitalization or providing of the internet in our. So one thing is like how is your big data different from your data or like small data that used to exist previously before somehow the coining of the word big data. So one is your data organization. We'll just now see like in like big data. So this data is mostly unstructured, and your small data or data is actually your structured data. For example, on a smartphone user, so there is audio data also, there is image data also, there is chat messaging data also. So there is, this is basically your text data, and you can have your mobile banking data, so your location access and sharing data, if you're writing about some product reviews and all those kinds of things. So all this is like your different kinds of structured data. Like in terms of you can have text data, you can have like your um, image data and audio data, so multimedia. So you can actually see there's no structure within. Like you cannot put in a particular file format. Okay, like only this file format is going to, the data is going to follow. And that's why like the related data, which is was like a small data, which was like mostly structured, you have mainly either only text data or only multimedia data or audio files. So this is one of the striking difference. Second criteria, that is the storage, in terms of the amount of memory that is required for like big data versus small data. So big data requires huge amount of storage. It's in petabytes, exabytes. It's that large amount of data. If it's not that large, so it's like small amount of data. So maybe your MB, GB, and in terabytes also, even terabytes also. So that's small data. So just like a very small example, if you have a local laptop or local machine, so whatever the data that you can store on that, or even your smartphone. Nowadays, smartphones also come up with huge amounts of inbuilt memory. So you can store that, or you can have your external hard disks also. So you can store TBs of data. So till that volume, that is your small data. Once it starts exceeding that, so it's no longer fits into your local machine or your external detachable hard drives also. So then that starts to border onto the big data side of the things. Next criteria is your data volume speed. So data which is generated exponentially, it's called your big data, and which is generated gradually, that is called your small data. So exponentially, we just now saw an example where the every minute on the internet, the amount of data that is generated is like huge amount of data is generated in terms of different snapshots or the logins, or in terms of the YouTube searches, in terms of the emails that are sent and things like that. So every minute, this much amount of data is generated. So this is like increasing at an exponential rate. That's what is categorized as the big data. And then is your small database, like grows gradually, accumulates over the years or the period of time. So then obviously, as said, so it is like data, it is like huge amount of data. So it cannot, all the data cannot be stored at one place. So this has to be distributed, and we'll see in when we come to discuss this big data technology, that is Hadoop. So in that, how your data is organized in terms of different distributions, you make chunks of the data, and how do you store this data, and then obviously like related terms are there, how you prevent against the crash and failures and things like that. As against your small data is like centralized, so you can store at one place, maybe one external storage on one local machine, or maybe things like that. So different types of technologies that are available to handle this big data, the Hadoop and Spark are very popular, and we'll see one very common name also, that's called Cassandra, that's also like very popular these days. For SQL, because like Hadoop and Spark, they come up with this certain set of uh, file systems and security features and different kinds of data processing capabilities, which are based again on the volume of the data that is in the big data. So your normal traditional processing is no longer fit to handle that. For small data, this compared to this like much smaller, so you can always handle that with your SQL Server or your Oracle. Then obviously like this data is coming at an exponential rate in huge numbers, in huge volume every second. So then you cannot handle it with a very small, very reduced capability machines. So you require very huge and very strong, powerful machines to handle such data, the traffic that is coming in for handling of the data. In general, we talk about here multi-node cluster. So cluster is just a group or collection of machines that are there. So that collectively perform certain tasks. So here you have a multiple machines, a multi-node clusters you have for processing of the big data. As against that, you have a small data, so there is always single node cluster because data volume is smaller and it's not coming in like huge volumes. So you can always handle that with like a single node cluster. So this was about the introduction to the big data, what it actually means. So I hope you must have got an idea about the big data per se, what actually it means, the in terms of the velocity of the data or the volume to which it is coming, and why it is a reality, cannot go back in time, and how it's different from the small data. So now we are clear with what actually, somehow in context, we are clear what big data means. So to and since this big data is an very important, it's a reality now. So how do we deal with such kind of data? Because as we just now saw, so it also gives very useful insights and can be very good for strategic decision making also. So how do we deal with that? So for that, we require a big data architecture, and we'll first of all see, like from a conceptual point of view, what actually a big data architecture looks like, and then when we go for big data architecture patterns, then we'll see how that's implemented in practice. So let's see. So big data architecture mainly, it has these broadly these categorizations. So we have data sources. So as the name suggests, so any place from which you can actually call it a location somehow, how your data is actually being fed into your big data system or the architecture. And mainly we'll see like there are three categorizations of the data. So there is structured data, there is semi-structured data, and there is unstructured data. And we'll see like how these are like categorized on what basis, why they're called structured, why semi-structured, unstructured, and things like that. So once this data is received from your external sources or data sources from in different types of formats, so you can either have a batch or scheduled kind of processing of the data, or you can have a real time or stream kind of processing of the data. And this broadly constitutes a data ingestion. So as the word suggests, so your data is coming from the data sources. How is that taken into the organization or ingested into the organization, and how that is transferred to the further processing? So these two blocks are somehow the actual strengths of the big data you can see. So batch processing data is somehow related to your historic data processing and things like that. And as the time is coming up and the big data technologies are evolving, so batch processing is somehow going down and down, and more real time and online processing of the data is taking up over that. So second is, as the name says, real time. So it's like online processing of the data, you can say, as the data is coming in. So how that is created, we'll see like what the real time views and things like that. So once this data is ingested, so then that is sent to your data storage layer. In that you can have different types of storage possibilities. You can have like RDBMS possibilities, relational database management system. You can have NoSQL. So how is NoSQL different from your relational? So any database management system which is non-relational is broadly called your NoSQL. So any kind of different type of architecture can be adopted. And then you can have HDFS. We'll say HDFS is your Hadoop distributed file system. So that is specific to your Hadoop technology. And you can have different types of systems that can be built on top of that. So you can either have uh, data warehousing kind of systems or ODS kind of system, data marts, and then this data can be hosted on the cloud or like on premise, like into the organization, or a mixed kind of approach can be followed. If like there is very large or secret data, some privacy concerns are there, so data can be like kept inside the organization on premise. And if it's like privacy concerns are not there and data volume is huge, so you can always post onto the cloud and things like that. Then comes a very important aspect. So as I said, because just storing this huge amount of data is not important to us unless we try to derive some useful patterns from this data. And this is what is constitutes your broadly your analytics or serving kind of servicing kind of thing from the big data. We have different kinds of um, options, or you can say like processing that we can do onto this data that is stored. And there's also possibility of running different kind of models and engines. So you can have like statistical models or statistical data processing. You can have machine learning, and you can have either recommendations or knowledge graphs or pre-computed views and things like that. And then finally, there's also the data consumption layer. So data consumption layer is whatever the data that is received from the data sources that is ingested, some data is stored and real-time data, then you perform analytics on that. So once those analytics are performed, so how can one obtain or like take the strategic decision? So that needs to be displayed to the people who are involved for the strategic decision making. And there are different ways. Either you can have like BI dashboard, that is business analytic dashboard. So different visualization approaches. You can either file the reports. Different data visualization technique can be there, either maybe graphs or charts or histograms and things like that, or different kinds of insights that you can generate from the data, or real-time alerts if you want to generate, or you want to go for back and forth querying with the data, maybe like cross questioning sort of thing. You want to enter into the data what if kind of questions. So then, or you can like have a enterprise data warehouse, you can store the data in there. For all these components to somehow work correctly, you have a data governance layer on that, and we'll see like different functionalities that are vested with the data governance layer, where you can have like auditing mechanisms and things like that. So let's now see each and every layer in detail. First of all, talking about the data sources, the as just now told, so there are basically three forms of data: structured data, semi-structured, and unstructured data. So in a structured data sources, so first comes your data warehouse, and we all know what is a data warehouse. Data warehouse is a large collection of data, and there are different ways in which data can be organized in the data warehouse. You can either have different schemas that arise from that. So there can be star schema, snowflake schema, and nowadays there are different types of data mining tools are also available on the data. So how efficiently you organize your data. So one way is your data warehouse, and that's strikingly differs from your normal day-to-day systems for the data processing, where you mainly the purpose is storing the historic data also in the data warehouse, and mainly it's used for the strategic decision making and by use of different kind of data mining tools that can be run. And data warehouses are generally if you one is running one organization, so they're enterprise wide kind of data storage or storage facilities are there. Then apart from that, then you have another structured form of data is your data mart. Why this is, comes in all this, we'll just now see like in why these comes in structured data once we have discussed through all these systems. So then coming about the data mart. So data mart is somehow you can say it's a subset of the data warehouse. And within the organization, so every department has a data storage, and that every department wise data that is called your data mart. And all these data marts, when they collectively combine, so they have some centralized mechanism for interacting with each other, exchange of the data, and that is collectively they form the data warehouse. Then these two are like structured because somehow the organization knows what kind of data it's going to generate or what all sources. So the organization or the schema over here is known. So based on the schema or some mechanism that is used for inducing the structuring over here is the schema that is there. So that's how. Then comes your OLTP. OLTP stands for Online Transaction Processing Systems, and these are systems which are used for the performing the day-to-day task of the organization. So OLTP systems are basically used for example, talking about day-to-day systems of your payroll generation kind of systems or monthly billing kind of systems that are used for performing the basic task of the organization in terms of the normal day-to-day processing capabilities of the data. Such kind of system constitutes of OLTP systems. And we know that OLTP systems because every day, so like they are used for collecting the data of one day or like every day. So when they collect data for over a month, then weeks and years and things like that, it keeps accumulating this data and then that is fed into the data warehouse. And obviously, like it's not that straightforward feeding. There's lots of data processing that needs to be done before that can be stored into the data warehouse. We somehow known as briefly the ETL processing, extraction, transformation, loading kind of things. Then we have operational data sources also. Operational data sources, somehow you can assume that they are a place where your data is collected from different data sources. It comes and it's stored, and then on that you can perform different kind of data processing capabilities or different kind of algorithms can be run on that. Then data can be cleaned and things like that, and then can be later on stored into your data warehouse, or maybe you can have operational data sources, ODS systems for your data marts also, department wise also, things like that. Then there are also your CRM system, CRM customer relationship management system. So in particular, every organization has a customer in some form of the other. So particularly these systems are recently become very popular because catering to the customer needs. The customer can have different kinds of queries, can have different kinds of concerns, different kind of complaints or feedback and things like that. So CRM systems somehow relate to uh, the task related to your customer handling activities. And then is your ERP system, enterprise resource planning system. ERP systems are concerned with somehow with the basic day-to-day activities of the organization and basic right now, like in universities also we have the ERP systems where you are generating payrolls or, for example, leave management system of the employees and reimbursement management systems. So these are your ERP systems, enterprise resource uh, planning systems. Now somehow this data is in the organization exists in either maybe possible with the data format that is coming in or with the schema, some kind of structure you can induce. There's a possibility that you can see through the data. Now comes your semi-structured data. So there is one very glaring example is your NoSQL databases. So in NoSQL databases, your data. So first of all, as already told, so NoSQL is any database which is non-relational. Relational databases are organized in the form of tabular form of data. When you go for non-tabular form of data organization, so this is your NoSQL database. So they are semi-structured in the sense. So definitely your schema organization somehow exists. But there's also a possibility that there are like null values or empty values, and the data is coming in the raw format. So then obviously like then you clean and like update, and then you store into your data warehouse. But before that, so NoSQL database is stage before that. And there's also a possibility that your data in, for example, talking about university setup, so you can have the data about student having your marks and like your personal information, academic information and things like that. Then semi-structured data is your also one possibility is your log files. So whenever you search on the internet or any kind of browsing that you're running, any program you're running on your system, any application, so automatically related to that, your log files are generated. And log files are very useful for error handling capabilities and things like that. So somehow they're human readable, and that's why they're called semi-structured. And you don't get like most of the it has the attached headers and things like that. So this like difficult to understand. So that's why semi-structured. Then you have your spreadsheets, and spreadsheets if they don't have any accompanying schema with them, so that's why they are semi-structured. Semi-structured because you already have the data, but your schema is not defined, so that's why semi-structured. Then we have HTML files also. HTML files are generated whenever you are designing any web pages and things like that. So those are semi-structured. You have your text data, you can have your images and things also, and the organization of data is somehow not that within that tight bound. CSV files, so you have your text that is available, that but that's comma separated. JSON files and XML files also, they are semi-structured, and right now these two kinds of formats are very popular in terms of data transfer because they are lightweight and they are easy to handle. Now talking about your unstructured data, so whenever this data is all at or one place, one form of the other. So that's why it's called unstructured. Mainly unstructured in terms of the different file format that is associated. For example, talking about your images and audio files. So your images are like either in JPG or PNG format, and audio files are in MP3 format. This file format obviously determines what kind of operation that will be performed in a certain file, how that will be handled, and how that will be stored, how much storage space that will be required, and things. Then you have another category of data that is unstructured data, that is your video data. So videos that come in online, maybe online videos or offline videos. So you have your MKV format, you have MP4 format, and different kinds of possibilities. Then comes your social media data, and definitely like in terms of the Twitter, Instagram, Facebook, etc. So all we have, whenever we have like done run famous machine learning algorithms on the Twitter data, or people who have worked on the sentiment analysis, they know that one of the very big challenge in handling the Twitter data is the cleaning of the data because it's very unstructured, tweets are incomplete, and whatever the data that I'm collecting, for example, like talking about the people referring to their first names as the salutations as the doctors. Some people write the complete word doctor, or some write like dr dot and things like that. So this is how somehow like very unstructured data and not clean also. Instagram definitely it's unstructured because you have your text data also, you have your video data also, you have your audio data also. So it's a combination of these three that is coming in, and same applies to your Facebook also. And Facebook is like even higher because you have data or information about the likes also, about the posts also, and possibly about the marketing ads also, and things like that. Then you have your next application kind of unstructured data is your in your messaging data, where you have your obviously SMSs, short messaging services, or WhatsApp chats, WhatsApp data, or chat data. So I'll just now tell you the example between the WhatsApp and chat. So WhatsApp we all know, so it's unstructured because you have can have text data also. You can send now. You can also send your files also. You can send PDFs. You can send different types of text files. You can also send your audio files or videos. You can share obviously like to certain size, not more than that, but that's possible. And then in your chat messaging over here specifically refers to the um, for example, whenever you go onto the website of a banking application, or nowadays most of the websites are allowing this, you have a chatbot kind of applications. So in that, whenever you chat with an agent, so this chat is also generated. So this also comes in the messaging data. Then you can have your location based data, obviously like geo data. And location data in terms of this geo data is somehow related to your geographical location and things, tracking your timeline. And location data is somehow refers to your whenever you're using kind of a mobile application, so you're asked to turn on your location and things. And then you can have data from your smart devices like from smartwatches, and you can have and nowadays smartwatches are equipped with more and more features where you can track your heart rate, your daily activity, and your different kinds of body vitals, things like that. And some smartwatches also allow you to read the weather of the day and things like that. So this is one where it comes in the location-based data comes in. Then obviously you have websites and web pages. So websites, you are browsing the websites of any organization or like in general. And web pages here, like I would like to refer to one very important component of web pages over here is that of the blogs that number of people are in the habit of blog writing. And apart from that, you can also have the websites for news articles and things related to that. So that is somehow you're unstructured because you have different kinds of, first of all, the data formats are also different. Then you had different kinds of uh, data forms, and news articles or news websites are also important where you're also recording people's reactions also, like just like up like in things. And same applies for your website data in terms of your YouTube and things where you have right now also the option to share, or you can also have the option to dislike, upvote or downvote, things like that. Then also there can be lastly but not the least text data in the form of the files like PDFs and things like CSV file, XML files and things, and that you are maybe sending mostly over the emails or putting on certain websites for downloading and things. So these are the broadly the big data layers that we will be have seen the data ingestion, storage, analytics, serving. So we have now the data that is coming in from the data sources in the any of the three formats, maybe structured, unstructured, or semi-structured, and then how that is processed so that we will see through the big data layers. So first is your data ingestion. So just as we discussed, so there can be batch or schedule. So that is mainly your historic data that is coming in. So maybe organizational policies or maybe mission vision and all those kinds of things, or some important past records that the organization believes in preserving and things like that. So one example can be whenever you join any university. So in a university, so you have maybe policies on the hostel usage or usage of library or anything like that. So that is a batch or scheduled data. When you have against this, you have a real time or streaming in data that is coming in. Then comes your data storage. So whenever data is coming from the data sources, that is ingested and then it needs to be stored in some formats. So most common formats are your RDBMS formats in the relational formal data. That's, by the way, most common formal data still in practice. And the relational database, we know that's in the form of organization of the tables. And then after a certain point, when obviously the table becomes very large, so you have to normalize the data, reduce the data redundancy, and you have to maintain the efficiency of your data. So all this related activities coming to the data organization. Same goes for your NoSQL also. And then we'll see like Hadoop system when we'll talk about this in detail into the big data technology. So Hadoop distributed fault tolerant file system is related to when you organize your data in different sizes of the files and replicate the data and things like that. Then once this is like individual pieces of the data, individual pieces of the file, so when collected together and aggregated, so then they form large storages of the data, and obviously because big data, so the storage possibilities are obviously data warehousing, data warehouses you can have, you can ODS systems and or your data mart kind of systems. Also, some organization nowadays also talk about the hosting of the data, so maybe like or through the websites or things. So one obviously possibility is either the cloud hosting or on-premise, and other approaches are mixed. So cloud data, if it's not very privacy or concerns are not there, for example, talking about the banking application, so you don't have your customers' personal records is one thing, so which is very sensitive or private kind of data or transaction history from which you always if some malicious person or program gets access of that, it always can steal the person's data from the bank or steal the money from the transaction. So all this privacy concerns are not there. So always better or to put the data onto the cloud. So cloud storage spaces from the Amazon Web Services or any kind of web hostings can be purchased. Or like you can put the data on premise, or obviously you can follow a mixed approach. Then once that data is stored, so obviously to uncover useful patterns from that, there's greater in use nowadays running the making use of the different kind of AI or artificial intelligence models that we can learn run on that data and uncover useful patterns from that. So one kind of very important like models can be used statistical models. And if, for example, talking about the weather forecasting and kind of things, so there is always a possibility to run this kind of statistical tools, statistical models, and when you have large mathematical derivations or backed by large mathematical models, then you want to go for certain kind of predictions based on that. So you obviously you have related is your machine learning models are nowadays very much prominent, and they are very much useful machine learning models, especially related to your deep learning models. They're very useful in your health data, especially health sector, health domain, and in you want to go for recommendation kind of things or you want to go for predictive kind of things. So recommendations are mainly when you are very useful for the marketing companies. Whenever a person buys one product, for example, person in a supermarket, so they track the data of the customer. If a customer is buying lots of bread, so then you always have to sell a relative product to the customer, maybe a butter, cheese, things like that. Then in health sector, whenever you want to go for a predictive sort of thing, and predictive is also possible in marketing also. So if a company or the agency knows that they one of their product or SKU is selling at a very high rate, so you have to always stock up that product more than compared to the other products, and obviously try to find out like what are the faults in the manufacturing technology or kind of things in which why other products are not scaling up and things like that. So all this is like in the analytics side of the things from the big data. And then to the users, obviously you can present the output in the form of knowledge graphs. But we'll see like, this is much more pronounced when you come to the next layer of the data consumption. Or you have like pre-computed views. So from the definition of a databases. So view is like, as it's called, the way of looking at. So view is whenever from the complete data you just extract a part of the data or a part of the table and then you try to view or generate certain recommendation based on that. So they are always pre-computed views can be stored into the memory, and they can be used for faster query processing and things. Then data consumption. Data consumption actually means consumption is from the end of the person who is involved in the decision making sort of thing. So how is the data or the analytics consumed by that person in terms of what kind of usefulness or insights the data brings. So one of the most common ways is your BI dashboard. That's on the business intelligence dashboard. And we know that's a kind of a framework or a software in which you feed into the data, and you can see the data from different kind of angles. You can analyze the data. You can either analyze the data through the summary in terms of your statistical measures like mean, median, mode, or things like that. So what is maybe like the average sales, what is the variations in the different cycles or the profitability of the company. Then you can always plot that onto the graphs. So there can be different graphs or histograms and things like that. That is possible. Then also there's a possibility of generating different kinds of reports from the. So one obviously is in form of a text report you can generate, or you can also generate a visual reports, which are a combination of the text and the visual, the images and things. If you want to like depict a process flow for an organization or certain things, so then there's this reporting in those terms is possible. And obviously, most important observation and application where this reporting is used is commonly seen is in terms of when you want to design a standard operating procedure for a certain application into an organization. Then another data consumption form can be your data visualization. So BI dashboard that they allow you the data analytics also in terms of your measures of central tendency, but data visualization is mainly concerned with your plotting of the different ways in which data can be seen and through pictorial means. So one is obviously through the different kinds of graphs, and you can always have in the whole of the discipline of the data science is concerned with that. You can have different kinds of visualization in terms of different combination of the parameters on different of the axes, and you can always see their trends, how they vary over the time. So how one data varies against the other. Maybe for example, the age of the customer with their buying patterns or buying trends, their expenditures, or age with income and their corresponding expenditure for a marketing company, maybe for a clothes or apparels company. And these kinds of visualization, they're possible to generate. Then obviously from this, you can have different kinds of insights, as I just now told you. So different customer buying patterns and things, and then obviously recommending the whatever the customer wants. Then there's also possibility of real-time alerting. So this is mainly concerned with your uh, this is very much useful in case of your internet of IoT kind of system, and very useful in predictive maintenance sort of systems. For example, if you have deployed a temperature sensor at certain point in your maybe boiler uh, in your company, which is like related to your steam handling or energy or power industry, where you have maybe like a steam going through a certain uh, flow, then you really want to predict at what time in the future, then this will require a predictive maintenance thing whenever that time comes. So you can generate real-time alerts. And also there's a possibility there's some maybe tragedy or things like that. Or in case of a banking application where you have like if a customer, for example, analyzing the past customer data, customer is generally not making any high value transaction, and suddenly one day there's a very high value transaction in the account of the customer. There's always an alert that is generated because there always a possibility of an anomaly that is being generated. Some things like that. And you can always go for searching and querying into this. So there's always a possibility of back and forth sort of thing. So where you can like if like I am analyzing this data and this report is sent to me. So maybe I know that my customer churn rate is very high or in a mobile organization. So if I want to see like which customer buys which mobile data pack most often, so I want to maybe search from this data or query from this data. What if I buy like show this customer this offer also? Can I give this customer an offer or not? And if there is a Also, then X number of people apply, for example, for a credit card to a bank. So then there's always a possibility of going back and forth with the system. Like if I issue the credit card to the customer, what is the percentage defaulter? Or if I give a loan, so how much can that be repaid and things like that. Then last but not the least is also your enterprise data warehouse. So where your complete data view is stored in the finally at the data warehouse of the that is enterprise available. And we have different stakeholders in the enterprise data warehouse and based on different rights. So there can be administrators, there can be strategic managers, and there can be people who are concerned with the day-to-day operations or day-to-day processing. So based on your working capabilities or your job description, so that person gets access to that different type of data. And for all these layers to work very good, so there's a data governance layer. So somehow you can draw a parallel with the database administrator in a normal database. So there are auditing mechanisms, there are security mechanisms, there are quality control, there are data catalogs, you can have metadata management. So obviously for security and auditing, you can define different kinds of protocols. Similarly for quality control, so you can have different kind of standard operating procedures or different kind of data catalogs. You can have different log files that can be stored for error handling and things, or you can have like different data metadata management and whatever all that comes in. So all that we just know. So one very important aspect that needs to be seen in this architecture is over and above all these layers. So these are merely, if you can say, like dumb blocks, unless these data flows add value into this. So this data flow is one of the very key concern or key aspect or striking feature of this big data architecture. So these are different types of data flow that can be there. So obviously, like one you can I just not talked about. So big data architecture also can have the storage of the historic data, but like right now, the trend is increasing towards the streaming data and real-time data. So more and more online data is coming into the practice. So for historic data, the data flow is broadly from the data sources, obviously like structured, semi-structured, unstructured. Then you go for the batch, the scheduled kind of data and goes into the storage. So you can see like this is a two-way flow over here. From data source, you can have a back and forth between the batch or scheduled, and then you can have your data finally going one way and getting stored into your data storage. Another type of flow that is possible in the big data is your push flow, data flow. And this is maybe very common nowadays, maybe in some kind of chat applications or like email applications. So where you go for the push notifications sort of things. So then data comes from your data storage and it's like goes from the analytics side of the things and then goes to your data consumption. And you can also have your real-time data flow. So it comes from the data flow, data source, and then goes to the real-time flow of the data, then goes into the data consumption, or you can have directly from your real-time, either goes to the data consumption, or you can go have the analytics side of the things where you want to analyze the data, generate certain trends or predictions and things like that. And real-time data storage can be from real time going to the data storage. So we just now saw like different kinds of data, big data, and how that big data architecture broadly look like. And you can have either data sources feeding into the data. You can have data injection. You can have from the batch form, or you can have real-time form, and then you have storage of the data. You have on that data you can run analytics, so you have analytic and servicing, and then you have data consumption, and to monitor all of them, so you somehow have your data governance possibilities over and above that. So now this is a conceptual point of view. We discuss about the big data architecture. How do we actually implement that big data into the practice? So that is what becomes your big data patterns. And two of the big data architecture patterns are very, very common nowadays, are very popular nowadays. So one is your Lambda architecture. In that, broadly we'll see, and the other we'll see is your Kappa architecture. So the basic difference between your Lambda architecture and your Kappa architecture is, in Lambda architecture, you have your batch processing is also possible. That means you're also processing the historic data. But as everything is going towards digitalization and nowadays most of the data is processed online in the real time manner. So, and this is because this is also the demands of the new customers and new age people, where they want the data content delivered at the very fast and high speed rate. So more and more shifting is towards the real time processing of the data. So Lambda architecture has your historic processing of the data as well as your real time processing of the data. As against this, you have your Kappa architecture, you just have the real time processing of the data. So in Lambda architecture, there are three variations that are possible in the Lambda architecture. One is called the batch only serving layer. So from the architecture, basic architecture, conceptual architecture that we saw, so data sources remain the same, storage remains the same, governance remains the same, and consumption. Difference comes in your other processing of the data, ingestion and the processing. So here you can see your batch layer has a serving layer where you have your batch or pre-computed views run on the batch processed data. As against this, your real-time data, so it's your real-time views. This is like a very integrated into one speed layer only. You don't have a servicing layer only for the batch layer separately. That is only historic data. Servicing, if you remember, so this somehow related to analytics. So this architecture combination as a so batch and real-time processing, there's a Lambda architecture. So batch will ingest data, it performs these computation, and these computation appear at a dedicated serving layer. And you have a serving and data consumption layer that is combined in one, and then obviously speed layer. It enables mainly it's like enabling the real-time data processing, and obviously like ingest data from the data sources and supplies data consumption layer, things like that. So this is where you have the serving layer just for the batch or the historic data. Another variation is where you can have a serving layer both for the batch processing as well as the real-time processing, and other things remain the same. So here you have a serving layer for speed layer also. Third variation is where you have a common serving layer for your batch data as well as your real-time processing data also. So now you can see this is one common layer that performs the task of batch and the speed layer or the real-time data processing also. So obviously needs to have more capabilities, and obviously checks and constraints need to be ensured that your historic data doesn't get mixed with your real-time data or the other way around, and how to compute the real-time views and things like that. And there are mechanisms or technology that exist for ensuring that. So there's a common serving layer for both the batch and the speed layer. Speed layer here refers to your real-time processing or the online processing of the data. Against this, so now you can see, as already told you, in Kappa architecture, you've completely got rid of the historic data. So there is no batch processing that exists. The processing, that is, all the processing happens in real time of the data. So it's for real time data processing only, and obviously I just now stated. So there is obviously got rid of the batch processing. So, but some people have different arguments. Some people say no, Lambda architecture is better. Some have different, say the Kappa architecture is better and things like that. So we'll just see some differences and how these two architectures play a different role in terms of the capabilities, or how do you differentiate between these. So assuming that we have like these attributes and these architectures, so and this Lambda architecture over here, we are referring to all the three variations, batch serving layer only and common layer and everything, all the three variations. First of all, talking in terms of the adoption. So Lambda architecture is always easy to adopt because all the existing data that we are using for the historic data, so already that system is in place for the systems or the APIs or whatever the protocols programs that have been written for the extraction, transformation, loading, ETL processes and things like that. So always that can be adopted, like from organization to like you upgrade your systems and things. So somehow you can always use those. In Kappa architecture, because your real-time data may be different, so this becomes slightly a challenge because your new data, new format comes in the real-time processing. So every time you have to have a new system or a new tech that may be required. Audio data may be processed differently from your text data and video data, things like that. Talking about the implementation, so this is because obviously like adoption in terms of the technology. So most of the code or you can say technology somehow already in place. So you can, yeah, and even if some organization takes time in developing, like the new technology for the online processing of the data, still it can get up and get started running the system with the historic data. So use of the existing ATL. So this is somehow simpler in implementation because you're always your half battle is one when you may process the historic data. So then here it's like difficult because all the data processing happens in real time. So till the time you don't have a system in place for the real time processing of the data, it becomes difficult. Here, obviously, like maintenance of the Lambda architecture will be difficult because you have to go for separate maintenance for the your historic data as well as your real-time data. And here it's easier because you have to just manage one system. Performance, it's better because obviously like you have your historic data and you have your real-time data also. So results are somehow faster in those terms. Here, a lot of attention needs to be paid to the event duplication and the sequencing of the data sequencing because all your data is in your real time that is coming in, so you have to really sequence which event occurs after which and things like that. And similarly, there's always a possibility that if your data, for example, is arriving in video format, so video is always transmitted as a combination of frames, so one frame may be duplicated and things like that. So some here it needs to be ensured. So here you can always see it's better. It's not said it's easy or the best. It's better because you somehow always winning on the side of the advantage of the historic data. It is already there. It's already you have a lot of process data that is already stored there. Whenever there is a real time processing of the data, it's always a challenge. So here that's like struggling in those terms. Obviously, your Lambda architecture will require more resources because more storage, more things like that. And it will require lesser resources because it's just processing here, it's processing more data, so it's processing lesser data. Code duplication, it's obviously like needs to be done because you have your batch and data stream. So here, most of the time you write a new code. And use case where like data is to be returned is like historic data and here's your typically online data. So maybe online video processing or real-time processing. This is one application of Kappa architecture. Maybe movies online, maybe Netflix, you can assume things like that. Here it's like your strategic decision making in terms of the banking architecture and things, where health is obviously one of the very good applications. So now moving to how do you, we have seen all this big data, how this thing is there, and now comes thing how you really implement this technology or on the ground. So, or the how the organizations are implementing this. So we saw Lambda and Kappa architecture, but their patterns in terms of the technologies. So these are three of the most famous big data technologies. One is the Hadoop, other is Cassandra, and third is Spark. And obviously, they are based on different kinds of platforms. So we'll see like different kind of programming languages and that they support. So we are going to discuss Hadoop in great detail, and let's see. So first of all, so this Hadoop mainly it has three components we'll be talking about, which make it like different or unique from other big data technologies. First component is the storage component of the Hadoop, and this is called your HDFS, Hadoop Distributed File System. So if you remember when we were talking about the data storage and things in the big data technology, so whenever you have a Hadoop system, so you have a Hadoop distributed file system. And what is the quality or the idea behind this Hadoop distributed file system? And from that, it really derives a lot of quality in terms of data storage. So whenever you have a large amount of data, it's always broken down into chunks of smaller data and stored onto the local machines. For example, like this is a 300 MB of the data that is there. So that is broken down into blocks of 128, 128, and 44. So now people always tend to think, or the students, whenever they study about the big data and they study Hadoop technology, so they're always concerned with like why this is 128, because this is a standard that is defined in a Hadoop distributed file system, that your this file is actually a block of the file or block that is created from this file, and the standard size is 128 MB. So standard, when you see like, so 128 and 128 like 256, so whatever the remaining, that goes into the third block. So initially you start making chunks or blocks of the 128 MB. How does this Hadoop distributed file system is good in terms of preventing against the system crashes and things? So this 128 MB of the data that we get, so it always creates the blocks of the data. So you can see it like creates AB, AC, CB and things. So you can see like every data, it created two blocks, and these are stored on different local machines. And we can duplicate. You can see like block A is stored on two machines. Similarly, block B is stored on two machines. C is stored on two machines. So why this is done and what is the biggest advantage of that? So you can see in the event of a failure or a crash of one machine, so still you can see the data can be recovered from other machines here. Like if you see over here, A and C was stored in second machine. Now in the event of a crash, so A and C stored on this machine is lost, but looking at other machines. So A, we can recover from here. B, we can recover from any of these two machines, or C can be recovered from this. So this is what is the beauty of this Hadoop distributed file system. Data split into different small size chunks and then duplicated to prevent against crashes. Once your data is stored, how does Hadoop process this data? And I saw the FDP schedule also, where you will also get a hands-on onto this technology of Hadoop. So this technology is called a map reduce. So in your traditional data processing, how this is different from your map reduce? So in this traditional data processing, you can see all the data, either your emails or your text or audio or images data, all the data is stored on one machine and processed on this machine. You're processing large variety of the data on one machine, and definitely this is like time consuming, because whatever the programs that are used for designed for processing the image data are not suited for designing your video data. So different data have different requirements. So that is, as against this Hadoop MapReduce, what this does is it divides this data into different processing units. So this email data, for example, will be processed on one machine, and this image data will be processed on another machine, audio data on third, and video data on fourth. And then finally, whatever the output that is obtained, it's aggregated and generated in the final output. Also, for even for these individual pieces of data, it adopts a technology. We'll see through these steps in the next video, where in the next slide, sorry. In the next slide, we'll see where this video data or the text data, whatever is there. So individually also, it uses a very good mechanism for breaking this data into smaller chunks for faster processing. So these are the steps that this MapReduce follows. For example, talking about a text data that is coming, for example, in some email. So assuming that this input is like Hadoop is a big data framework, it can store vast amount. This is a large piece of text that is available. So Hadoop processes big data. So in the first step, this is the input that comes in. This input is then split, maybe of different sizes. For example, over here, the split was made on the basis of sentence by split. Maybe like first sentence, Hadoop is a big data framework, then it stores vast amount of data, processing data, and things like that. So split was on the basis of the sentence by split. Then in the next phase after split, so there is a mapper phase. What mapper phase does is like it stores that every sentence that it took, it stores the occurrence of a particular word, number of occurrences of a particular word in this sentence. So individual sentence like Hadoop is a big data framework. So every word over here occurs once, so it records that occurrence. Similarly for the second word, similarly for the third word, and so on. Then next step is shuffle and sort. So what does it does? It shuffles and sorts this. For example, over here, it in this maybe one way of shuffling and sorting is that is performed is where it clubs the similar words together. You can see like all the Hadoops that go to one place. So is aggregated one place, is occurs only at one place, so it comes over here and things like that. Then finally in the reduced phase, where it obviously sorts these words in alphabetical order and also stores their number of occurrences simultaneously. So you can actually see here it's summarized in this form. So this is one way MapReduce works on the text data. Obviously, this is like time saving and also faster processing of the data. You can see. So this is how this MapReduce works. Now, the third important component of the Hadoop is the yarn. Yarn is actually also called your resource management. It says, for example, over here you can see if your different type of data is there, so different type of data requires different type of technologies to store. And this is what is Hadoop does. In Yarn, it has different functionalities that are available. It has either a resource manager or a node manager, an application master, or a containers. Containers, you can say collections of the resources. So to process the big data in Yarn, you have containers, which are collections of the resources. So whenever a kind of processing you can see that needs to be performed on a big data, so this query is raised to the node manager. Then this application master also raises this query. Then these resources are sent to the resource manager. And through this resource manager, they're allocated to the particular application. So these are the three main components of the Hadoop technology. What are the applications of the Hadoop? Obviously, the data is stored and processed, and for generating different kinds of applications and very useful applications have been produced from the Hadoop and used in day-to-day scenarios. One application has been in improving the user experience and reducing the churn rate in the games. For example, what a game designer does is it creates different versions of the game. This has been very useful in these two games like Halo and the Call of Duty. So it creates a version of the particular game, the game designer, and obviously that game is sold to the users or like allowed to like have a freeware and things. Then the user plays the game at different points in time where the user pause the game, restart it, or quit the game. This is recorded. Then this data is all these time instances are recorded and this data is analyzed for creating a better user experience, because if the user is finding particular level very hard or finding it good or like passing out very easily and things like the user wants certain harder games and things, this is for creating better user experience and obviously reducing the customer churn rate. Otherwise people will not derive the pleasure out of like playing the game. Another application that was done in real application was of the disaster management. So in 2012 there was a hurricane Sandy that hit the coast of the America, and in that this through big data analytics it was possible to predict the hurricane's landfall 5 days in advance. So in 2012, so there were different kind of parameters that were recorded for this hurricane, and different kind of applications, maybe like weather conditions or maybe wind speed or all those parameters that were recorded. This data was analyzed and it was possible to predict like 5 days in advance when this before this hurricane actually hit the coast of this uh, continent, and therefore this prediction in advance gave the advantage that rescue measures could be easily taken and there was not much loss of the life and property for the people. So with this, I conclude my talk, and these are the references if someone wants to like build on into the future. So these are some of the latest uh, research papers that are published. So you can actually see big data is being used in accounting systems also. It's being used in big data management. There's a lot of work going on the object detection side of technologies, big data management algorithms for deep learning based object detection. People are also using it in the healthcare or in the banking systems. So these are some of the latest applications, and you can see like it's also used in finance, in green technology, in hospitality and tourism. They are used in healthcare, cybersecurity. Combined, this is an application cognitive side of the things. This is over a survey somehow that was published in 2022, and also people are using it in the neural networks and deep learning in wireless communication. These are some of the video references for you to further, if you're interested in investigating into this realm of big data. These are the blogs. So this is one of the very good blogs that I saw. That is by Microsoft. It gives details on the big data architecture. And this is one another blog that is available. So I thank you all for your patience and time. Thank you so much.
Thank you so much, sir. If any queries, anyone from you, you can just type in the queries in the chat window or just raise up your hand. So I heartily thank the key speaker of the session, Dr. Prashant Gupta, who kept participants engaged by a very interactive lecture, a very knowledgeable lecture, sir. Thank you so much for sparing your valuable time for us. Thanks a lot, sir.
Thank you, ma'am. I also thank you for giving me this opportunity. And I like if I'll be also sharing these lecture slides with the you and like if possible. So anyone who is interested can get in touch with me on my email ID also.
Yes, sure. I'll share the lecture slides on the group. If anyone interested, you have your complete profile. You can just get in contact with sir on the given mail ID. Okay. Thank you so much. Thanks a lot, sir.
Okay.
Thanks. We'll all meet you again at 1 o'clock for another valuable session. So a break time for 1 hour. Meet you all at 1 o'clock. Thank you so much.